Hello all, today we're going to be talking about the Algebra 1 January 2018 Regents exam. You can find the link in the description box below. I'm starting with a cleared calculator and we are actually on to the constructed response. So it says on the set of axes below, graph the function f of x equals the absolute value of x minus 3 plus 2. So how you get the absolute value in the calculator is by pressing second, 0, and then enter. The reason why you do that is because you're actually accessing the catalog, so you can see it's in blue here. And the catalog has a complete list of every function in the calculator alphabetically. So if you press second, 0, and then enter, you're going to get the very top of the list that says ABS, that is absolute value. Okay, so first I need to go into y equals. I'll press second, 0, enter. And I'm going to type x minus 3 inside the absolute value symbols. Then I'm going to use the right cursor to come outside of the absolute value symbols and then type in plus 2. So now I'm going to go to second table. And these are a whole bunch of values I can choose to plot. So I'm going to start with 0, 5. So 0 means do not move left or right, only go up 5. So 1, 2, 3, 4, 5. And then the next value is 1, 4, 2, 3, 3, 2, 4, 3, 5, 4. And then you'll kind of see this pattern that's formed here. So I'm going to continue the same pattern going outwards. If you're uncomfortable with that, you can scroll up and down in the graphing calculator in the table to determine more values or more points rather that you'll be able to plot. So the same thing's going to happen on the other side. And then using your ruler, you're going to connect all of this to create the V shape, and that is a characteristic of an absolute value function. Please make sure that you extend all the way to the edge of the graph, and don't just stop it here and draw little arrows. It has to go all the way to the end and then include your arrows. The reason why we're including arrows here is because they do not give us a limit on the domain. They only tell us to graph this function, and then we go ahead and graph it. All right, so we can also make sure that we label this as f of x equals the absolute value of x minus 3 plus 2. All right, let's take a look at number 26. Number 26 says, determine all of the zeros of m of x equals x squared minus 4x plus 3. So anytime it says determine the zeros, the synonyms for zeros are roots, solutions, and x-intercepts. So x-intercepts is what you would see on the graph itself. This is algebraically, so there are three methods we can use. We can attempt to factor, and then the zero product property. Then we can use the quadratic formula, or we can actually complete the square. Okay, so the easiest method is always to try and factor it. Okay, now obviously you do not have to do these three methods. You can just pick one and work with it. But just for this video's sake, I'm going to show you all three because you never know what the next one might look like. You might need to use the quadratic formula and so on. So when it says determine all the zeros, that means that your y value is 0. So this is 0 equals x squared minus 4x plus 3, in which I can actually put the equals 0 at the tail end. So I have to identify the sum. The sum is negative 4. The product is a positive 3. List all the factors of 3, 1 and 3. These are both negative in order to make a negative sum. And I'll write out my factors as x minus 1, x minus 3 equals 0. Now I apply the zero product property. X minus 1 equals 0 or x minus 3 equals 0, and I solve. So add 1 to both sides to get x equals 1, or add 3 to both sides to get x equals 3. I actually have a video on these three topics. I'll include the link in the iCard above. So now we can do the quadratic formula. If you don't know where it is, you have to go to your reference sheet. It is at the back end of your Regents exam. It is x equals negative b plus or minus a square root of b squared minus 4ac all over 2a. And I need to start by identifying A, B, and C because that's what I'm going to plug into this formula. So A in this case is 1, B is -4, C is a +3. So I'm going to plug this into the formula. I like to set up parentheses first before I plug in. So I will set them up like so. And then I plug in according to the formula. So I'm going to have B, B, A, and then C, and then A at the bottom. So this becomes -4, -4, A, and C, and the denominator is -4. Sorry. Okay. I'm sorry, just 1. My bad. Excuse me. So I always like to pull what's underneath the radical off to the side. So I'm going to simplify this on its own. So in my graphing calculator, everything under the radical is what I'm going to put in the calculator with the parentheses and all. -4 times 1 times 3, and I get the square root of 4, which the square root of 4 is 2. So this is the number I plug back in place of that entire radical. If you wind up with something like radical 5, which you know is an irrational number, you can put the entire radical back. So now I'm going to have negative on -4 is a +4, plus or minus the 2 for this entire radical, and the denominator is 2 times 1, which is 2. This is split into two possibilities, 4 plus 2 over 2, and x equals 4 minus 2 over 2. So your answer is 3 or 1. And that's the same 1 and 3 we have over here. Last but not least, we could also solve this by completing the square. So x squared minus 4x plus 3 equals 0. I'm going to subtract 3 from both sides to start. X squared minus 4x plus something that will make this a perfect square is equal to -3 plus something to balance the equation. -4 divided by 2 is a -2. Squared is a +4. That's what will make this a perfect square and adjust our equation. By factor, this is going to be two numbers that multiply to 4 that also make -4 is -2. So this becomes x minus 2 squared. Also notice it's what I divided by. I divided by 2 to get that number. And then I'll have -3 plus 4 is 1. Take the square root of both sides. X minus 2 equals plus or minus the square root of 1, which is 1. Then I will add 2 to both sides, and I'll be left with x equals 2 plus or minus 1. So x equals 2 plus 1, which is 3, and x equals 2 minus 1, that's 1. So again, your choice, the easiest one was probably factoring and then the zero product property. The second easiest might be the quadratic, because anytime you have a quadratic equation, you are able to use the quadratic formula to determine the zeros. All right, so let's take a look at number 27. The distance traveled is equal to the rate of speed multiplied by the time traveled. So right off the bat, distance is equal to the speed times the time. If the distance is measured in feet, so this is in feet, and the time is measured in minutes, then the rate of speed is expressed in which units? Explain how you arrived at your answer. So speed is what I'm looking for. So I can actually divide both sides by the minutes, and you'll realize that speed, which is not the question mark, sorry, that speed should be given in feet per minute. So your explanation could be speed is in feet per minute because, and you always have to make sure you have a because, especially when it says explain. They want a sentence explaining what you actually did. So speed is in feet per minute because I set up an equation and solved it. I mean, that's acceptable. I mean, that's what I did. If you found a different way to do it, that's fine, as long as you arrived at the right answer and it mathematically makes sense. All right. So let's take a look at number 28. Determine if the point 0, 4 is a solution to the system Solutions make inequalities true. Solutions make equations true. Solutions make stuff true. That's just what it is. And then it says, justify your answer. So, the point 0.04, be very careful, because in this example, notice how they indicate this end point on the scale is 10. But I only have 5 lines to get there, which means you actually are on a scale by 2. So a lot of students often made this mistake because they counted up 1, 2, 3, 4 and gave the correct answer that it's not a solution, but for the wrong reasons. Okay, so 0.4 is this point right here. And is this a solution to the system? The answer is no, this is not a solution to the system, because this point, although it lies on a solid line and near the double shaded area, which is our solution set, it also lies on a dashed line, which means it is not a solution to this inequality right here. So therefore, since it's not a solution to 1, it's not a solution to the system. So your answer written out might be no, because 0.4 lies on a dashed line and is therefore not a solution. Okay, I hope you enjoyed. I'm going to be posting the next video in a moment for questions number 29 and beyond. Have a nice day. Bye.